Hello and welcome to another SuperNEC Basics Help video where today I'm in the output interface and I'm covering the near field viewer. As is the case with the 3D and 2D radiation pattern viewer, the near field viewer allows for rapid 3D visualization and exploration of the near field data that is available from our assembly. In this section I'm going to be explaining to you how to thoroughly use the capabilities of this viewer and its features. The first thing we'll be covering, and I know the text box in front of you right now is quite daunting, but we're covering it now, is you need to select an active dataset for your near field viewer. The near field viewer actually holds more data than it can display, and each data point it actually holds consists of 4 different components. Our polar components, in other words the X, Y, and the Z, and our total field strength. Along with these 4 components, they have 2 properties each, in other words the magnitude and the phase. To add to the complexity of the near field viewer, the data it contains can also have a complete description of the near fields of multiple planes and at multiple frequencies. To combat this, a lot of the software used for near field analysis actually deals with only one plane and at a particular frequency. Therefore, it is the responsibility of the user, i.e. you, to select the plane, the frequency, the component and the property you would like displayed. The first component of our near field viewer we're going to be selecting is the plane. You'll see in the banner above that there is a plane pull-down menu. Here you'll be able to select from X, Y and Z planes and they can be passed to the near field viewer. You can even pass all the planes to the near field viewer. I do have to point out that if the near fields were computed in a single plane, for example if you set your X value to be a constant of for example 2.4, then the plane selection will be locked at that constant X value as opposed to a varying X value. So go up to plane, press Y, plane, X, and then you can select your Z plane. Since you've now selected your plane, our next component we're going to be dealing with is specific value in that plane. You can see here we're dealing with the Z plane at the moment, and you can set a specific value using the edit box over here or by going and using the slider over here. Recall that I mentioned the complexity of the data contained in a near field viewer. So data may not exist for your specific value, and if it does not, then it'll snap to the nearest existing dataset. What this means, interpolation does not occur in this viewer. So you can see there the slider, it snaps to the nearest value, and I can also just edit it. Moving on to component and property selection. Our near field viewer allows us to select the specific component we'd like to view and the property of that component we'd like to display on our actual plot. We can do this by going into the View menu option. The total magnitude of the near field is displayed by default. It is important to note that the color map is actually going to be where the phase plot is viewed. The near field viewer does not unwrap the phase plot, so basically what that means is that 0 degrees is not going to be a similar color to a phase of 360 degrees, even though in Cartesian form that means a full rotation in either case. So a single color map, HSV, wraps around. So the phase plot is going to look wrapped. So go down to View, press Phase, View Magnitude, you can view the X component, Y component, and obviously the Z component, and lastly total. Color map, HSV as I mentioned, color map down to jet, which was what we started off with. To plot our actual data points, we have a number of different options and you can select them up here from the Type pull-down menu. So you go Type and go Mesh. Mesh, as was the case with our 3D radiation pattern viewer, is just our data points are joined by small wires. All hidden lines are removed in this type of plot. Go back up to Type, select Contour Flat. As the name suggests, the data is now going to be plotted as contour lines, and this is going to be located in real space. Go back up to Type, select P-Color. So we've dealt with the P-Color plot, for example, in the 3D radiation pattern video if you want to have another look at it. It's basically a more detailed depiction than a contour plot. It creates a surface in real space where the color at each point represents the data in that specific defined area. The last type is going to be the surface type. As was the case again from the 3D radiation pattern viewer, the surface plot is a complete surface representation of our actual assembly. And once again, 3D plot, shading and lighting are going to be a very dependent property we need to work with. The two plots I actually haven't covered because they're pretty self-explanatory are wireframe and 3D contour, so please feel free to look at our 3D radiation pattern viewer video if you want further details on those two. You would have noticed while I was doing the plot types that we were actually dealing with two distinct categories of plots. The first type was what's known as a pseudo-surface type plot, where we're actually using the height of our plot in the third dimension to represent our magnitude in phase. Then we have something known as a coordinate surface plot, and this is where data is represented in true space, i.e. it's going to be spatially located. This is going to be restricted to our 2D contour and our pseudo-color plots. As I mentioned, lighting and shading plays an incredibly important part in the visualization of near fields, 3D radiation and such. MATLAB has incredibly versatile lighting and shading facilities that you can actually access by going up to the Options menu and selecting the lighting option or the shading options. Options, shading, flat shading. Options, shading, interpolated. Go back up to Options, Lighting, go Flat, Options, Lighting, go Round, Options, Lighting, go down to Fong. I'm just quickly going to run you through the other items on the Options menu. For example, you can turn the grid on or off. Go up to Options, click Grid, you can see it displayed there. You can also actually turn the access box on, which is basically going to box your entire near field plot in a kind of border. And you can also turn it off there. So I go box, and you can see it's all around it. Switch it off. And the last thing we're going to be exploring is you can change the title. So Options, Title, and just change it as you'd like. Near field. If, for example, you'd like to be a lot more technical or you're doing this for a lovely project or something, you can change the X label. You can change the X label. You can go up to Options, press X label, and do that. I've just named it X label. Y label, exactly the same story. Go up to Options, select Y label, and the Z label is exactly the same story. So go up to Options again, press Z label, just edit that, Z label. And that's pretty much all I'm going to be discussing with regards to the near field viewer. Please feel free to ask us any other questions in the comments, and have a great day.